started. 4.1. So 4.1 is all about relations and functions. You're just going to be solving. Sometimes you're solving for domain, range. For this one, what we are doing, get some stuff settled in. We're going to take this x minus 1, and because it's in this parentheses, we are going to shove it inside of this. So we're going to take this x minus 1 and throw it into here. So the function of x minus 1 equals the square root of x minus 1 plus 4 minus 4. Since it's inside the radical, what we can do is look to see if we can simplify this. Good news, we can. So this will drop down into x minus 1 plus 4 minus 4. Again, these are just numbers that are sitting out or inside of the radical. So we'll just say x plus 3. 4 minus 1 is a positive 3, and then minus 4. You might be tempted to combine these together, but remember, this is inside a radical, this is outside the radical. They don't play well with one another, so we're going to leave it alone. So for us, the function of x minus 1 is equal to the radical of x plus 3 minus 4. So let's get this going. Square root x plus 3, right arrow key, minus 4. Submit. Hey. We're going to leave that keyboard up, and we are just going to scroll. Cool. For this one, it's asking for the domain. Domain is looking for any restrictions that x can't be. So if I look at f of x equals negative 10 over x minus 7, the only part of this that contains something that I have to worry about is the bottom. So for domain, we're looking for bottom with x's, and we're looking for radicals. Since this one has a bottom, we're going to take that bottom with an x and set it equal to 0. From here, you're just going to solve it. So plus 7, x equals 7. And really what we're saying is that x can't equal 7. So we can use any number but 7. With this software, unfortunately, we have to go the long way by saying that. And so we'll say parentheses, negative infinity to 7. And then from 7 to infinity. These parentheses, as a reminder, just help with saying that I can get to 7, I just can't touch 7. So we're going to take this and throw it into this. So we're going to need a set of parentheses. We're going to do negative infinity, comma, 7. And then we're going to do the u, just saying that we got more to talk about. And we'll do 7, comma, infinity. There we go. Next. When we're looking at this one, this one's going to take a little bit of time, unfortunately, but not too much. So for the function f of x, we have negative 8x minus 8. And what they want to do is determine the difference quotient, where it's f of x plus h minus f of x over h. Again, this tells us exactly what we need to do. We're going to take this function of x plus h, and we're going to shove it in right there. But we also have more things to consider. So the first thing we're going to do is just write our function out. And we're going to start by saying -8. And normally we're supposed to write x, but instead of writing x, what we're going to do is write what we have in that parentheses. We're going to replace x with x plus h minus 8. So that completes this first part. Then we need to do the rest of this. So we're going to say minus, and we're going to drop in my function. My function again is negative 8x minus 8, all divided by h. So now we have this statement that is extremely long, but what we can do is start to simplify. So I can multiply by -8. So I get -8x minus 8h minus 8. Then the negative sign gets distributed in, so plus 8x plus 8 all over h. If we look at that top, there's a lot going on. So what we're going to do is try our best to combine the things that look the same. So here I have a -8 and a positive 8x. So if I combine those two together, 8x minus 8x is 0. If I have 8 and I subtract 8, those are gone as well, leaving me with -8h over h. And one final simplification says h's cancel, and this whole thing just equals -8. Domain and range. One of my favorites. So again, we will scroll over and down and around. And what we're looking for here is some music in the background. So what we're looking for here is domain. And domain is just two parts on a graph. It is left to right. Range. Bottom to top. Okay. So domain. What we're looking for is, if I look at this blue line, how far to the left does this blue line go? And I get a lot of people that are saying like right here, but if I continue on, this line keeps going. If you notice, I have this arrow. This arrow is pointing both up and it's also pointing out to the left. Because this arrow is pointing out to the left, we're going to say that this domain starts at -infinity. Because of that, we're going to then follow this blue line, and we're going to go to the right. And we're going to look again. What's the furthest right that this arrow will go? And as we follow this up and to the right, we notice that, hey, we run into another arrow that's pointing both up, but also, and more importantly for domain, to the right. Since I have an arrow that is pointing slightly to the right, we're going to say that my domain goes to +infinity. For range, we're looking from the bottom to the top. So what is the lowest that this blue line ever goes? Well, if I look, this part right here is the lowest that I will go. What is that? Well, that's -3, and I can count it down by going, this is 0, -1, -2, -3. If I was going up, then it'd be 1, 2, 3, whatever. But since I'm going down, this is -3. So I know that my range starts at -3. And I'm going to use a bracket on this -3 because this is a line I can actually touch the point -3 with this. It's a solid line, so it's going to be at -3. And we're going to look for the highest point. The highest point is just, again, follow your blue line. Follow it both ways. Either time, though, you run into these arrows are both pointing up. Because you have at least one arrow pointing up, your range goes to infinity. Now the fun part, typing it in. So for domain, we're going to use a set of parentheses, and we're going to say -infinity, comma, infinity. And for the range, because we have a bracket and a parenthesis, we'll use this one. And we will say -3, -3, comma, infinity. The next part just says, is this a function? And for functions, you're doing a vertical line test. So if you draw a vertical line through any part of this graph and it connects more than once with this blue line, then it's a no. If I draw my vertical line right through here, well, it only intersects once right here. So for us, we're going to say that yes, this is a function. So again, domain and range, this is the equation that they give us. We'll have to do something with this here in a little bit, but for right now, they just want domain and range. So because they give us a graph, we can just look at the graph. How far left does this blue line extend? Well, if I keep going left, I run into this arrow that's pointing left and down, but for us, it's pointing left. So again, my domain will be starting at -infinity. And then if I look at the right side of this, it's also an arrow pointing to the right. So for this one, where we have 4y minus 2x equals 6, but a graph, I know that my domain is -infinity to +infinity, and my range is the lowest to the highest. So what is the lowest that this blue line will go? This is the lowest, and if I notice there's an arrow, this arrow is pointing to the left, but it is also pointing down. For range, I want this pointing down, and that means that it is -infinity. For the top of my range, again, I'm following the line. This is the highest point. It's an arrow. That arrow is pointing to the right, but it is also pointing up, so that my range is also +infinity. So again, we get a type. Double parentheses, -infinity, comma, infinity. And then for my range, -infinity, comma, infinity. This again wants us to determine, is this a function? And again, if I draw a vertical line through it, this vertical line only crosses once. So yes. Got a little bit more room on this one. Oop. Ooh, wait, I like that. Alright. So, again, it wants us to do all the weird woobly whoops. X plus oops. F of x equals a -2x squared plus 5x minus 6. It wants us to find x plus h minus f of x over h. For those of you that are going to move on, this is something that you find a lot in pre-calc and calculus. So let's do it. Again, you are replacing this right here into my x's. Okay. You're going to start off though by just writing what you see. So we're going to start off with the function -2, And then instead of x squared, we're going to say x plus h squared plus 5 times x plus h minus 6 minus negative 2x squared plus 5x minus 6 all over h. And now the unfortunate part. We actually got to do it. So when we look at this very beginning, remember that the square is before this. PEMDAS says parentheses, exponents, multiply, divide, add, subtract. Parentheses is just to look inside. Can I do anything inside the parentheses? If I can, great, do it. If you can't, then don't. Then I look at exponents. Multiplication and division occur at the same time. Addition and subtraction occur at the same time. So we're going to take care of our square first. That might be a little bit too light. So, negative 2, and then x plus h is squared. So we can write it as x plus h times x plus h plus, and because we're here, we might as well start doing a little bit of multiplication so we can simplify just a little bit quicker. 5 times x is 5x. 5 times h is a positive 5h minus 6. Again, the negative sign gets distributed to everything inside the parentheses. So negative times a negative 2x squared is a positive 2x squared. Negative times the positive 5x is negative 5x. And negative times negative 6 is a positive 6 all over h. Unfortunately, we still have that very beginning that we need to deal with. So let's do it. This part I'm going to do first. So you're going to FOIL. X times x is, x squared. X times h is a positive xh. H times x is another positive xh. Then h times h is a positive h squared. I did that in parentheses because, again, that square happens first. I want that multiplication to occur first. Then I can worry about this negative 2 up front. Since we're here, again, it's one of those times that we might as well look at what we have to see if we can combine and simplify anything. For me, if I look, I have a 5x and a negative 5x. Well, what's 5 minus 5? 0. I have this positive 5h that doesn't match with anything, so plus 5h. I have this 6, negative 6, and a positive 6. Whenever I combine those together, they disappear, and I'm left with a plus 2x squared, again, over h. You are about to hear a trash truck. I am sorry. From here, though, we are, again, just moving as quickly as we can to simplify and to combine what we can. So for us, we're going to take, not that yet, excuse me. We're going to combine what we can inside of our parentheses. So negative 2 parentheses x squared, excuse me, I'm still working, plus 2xh plus h squared plus 5h plus 2x squared all over h. Again, if I have one xh and I add another xh, I get two of them, so 2xh. Distribute. So negative 2x squared minus 4xh minus 2h squared. Do I have an eraser? I don't know. I don't think I do. Which is really sad. Plus 5h plus 2x squared all over h. Again, this is just negative 2 times x squared, so negative 2x squared. Negative 2 times a positive 2xh, so a negative 4xh. Negative 2 times a positive h squared is a negative 2h squared plus 5h plus 2x squared all over h. And we just keep going. Since I distributed, my parentheses no longer exist, and I get the lovely ability of going through and simplifying. So for us, if I look, I have a negative 2x squared and a positive 2x squared. 2 minus 2 is 0. Looking at the rest of this, nothing else matches. I have a negative 4xh and a positive 5h. Those aren't the same. I have a negative 2h squared, which also doesn't match with anything else. So we're just going to write what we have. Normally, we're going to put our squares first. So we're going to say I have a negative 2h squared minus 4xh plus 5h divided by h. Well, again, I need more room. And again, we are just trying to simplify. If we look, what do we notice that every single one of these contains? The letter h. So let's divide everything by h, leaving us with negative 2h, because remember, I have 2 of these. If I remove 1, I'm left with 1. Minus 4x, because h over h cancels each other out. And then lastly, plus 5. Assuming that everything went well, let's see if we did it right. So first we got negative 2h minus 4x plus 5. There we go. This is going to be one of the longest ones you encounter, so hopefully you don't see it too many times. For the next one, we are rewriting as a function of x. When it says rewrite as a function of x, you would think that you're getting x by itself. You're not. You're actually getting y by itself. This part right here really helps in figuring out what they're actually wanting you to do. So f of x is just y. It's a fancy y, but it's just y. So we can take our negative 2x minus y equals 5x minus 2y, and we can solve it in terms of y, or in terms of x, but getting y by itself. So if we want y by itself, I'm going to add 2y. Negative 2x. 2y minus y is a positive 1y equals 5x, and 2 minus 2 is 0. I'm going to add my 2x because it's negative. The opposite of subtraction is addition. So I'm going to add those two together, and I'm left with 1y equals 7x. I don't really like 1y. I usually just write it as y equals 7x. And again, f of x is the same thing as y. Whoops. That's why you don't write and talk at the same time. So f of x equals 7x. So over here, we just got to write 7x. Then it wants us to actually do something. Again, you can click on this previous step. If you get the previous one wrong, you can still get this one right by doing that previous step answer, at least on Certify. And all they want is for us to say x equals 1. So here they want to say f of 1 equals 7x. So y equals 7, but instead of x, we're going to put whatever's in the parentheses, or for us, 1. So y equals 7, or f of 1 equals 7. These two things, they mean the same thing. So for us, it's an easy equation, 7. And then now we're looking for step 3, which is the domain of the function. So to find the domain of the function, we're going to look back here at this f of x equals 7x. So if we look at this, what we're looking for again on domain is a bottom that has a letter or a radical. And if I look at this, there's no bottom to this equation and there's no radical. So x can be anything that it wants, and I won't get a 0 or a negative number that can't exist. So for us, we're going to say that our domain is from negative infinity to infinity. Okay. And again, you are determining something. So determining just means you're going to plug some stuff in and see what pops out the other side. So we'll start off by writing it. H of x equals negative 2x over x squared minus 10x plus 25. They want us to find h of x squared. Again, all this says is that for every x that you have, you're going to replace that x with x squared. Ooh, did not realize that I'm off. One moment. There we go. So from here, all we're doing is replacing our x's with x squareds. So h of x squared equals a negative 2 times x squared over x squared squared minus 10 times x squared plus 25. From here, we just need to simplify. So we're going to simplify what we can. We're going to take negative 2 times x squared. So h of x squared equals a negative 2x squared over x squared squared. Here we're going to multiply our exponents. So this becomes x to the 4th. Negative 10 times x squared is a negative 10x squared. And then my 25 just gets to hang out. So again, now we take this, throw it into here. Got to make a fraction, and then start typing negative 2x squared. On the bottom, x to the 4th, right arrow key, minus 10x squared, right arrow key, plus 25. There we go. Determine the domain and range for the relation. The range R equals this. X is all ends and Y is all this. Submit? Yeah. I hate these. A lot of it just comes down to reading this part. X is all, I think this is natural numbers and this is something else, but N and Z, because this right here. Domain is X, X is all N's, so your domain is the letter N. For Y, Y is all Z's, so Z's. Gross, but okay. Again, you're going to rewrite, because we love rewriting things. Look at me. Y plus the square root of X equals negative 3X plus X minus 5 squared. You could do a lot here. You can also be extremely lazy. Remember, all it wants is that Y is by itself. And if we're lucky, it'll accept it. If not, then we'll actually have to go through and combine like terms. I'm hopeful that it's just nice to us today. Minus square root of X. Yep. And again, all it says is replace every single one of these X's with a 1. So here's an X, here's an X, here's an X. So f of 1 equals negative 3 times 1 plus 1 minus 5 squared minus the square root of 1. And we just start doing it. F of 1 equals negative 3 times 1, so negative 3, plus 1 minus 5 is negative 4, squared, minus the square root of 1, which is 1. F of 1 equals negative 3, plus negative 4 squared is 16 minus 1. Last but not least, f of 1 equals 16 minus 3 minus 1, so 16 minus 4, which is 12. So 12. Submit. Go. Determine the domain of the function found in the first step. So here is where we have to look at this original equation. And again, I'm going to say for domain we're looking for two things. We're looking for x's in the bottom, or we're looking for square roots, even roots. When we look, we don't have a bottom, so I'm not worried about this one at all. But we do have a radical. And because we have a radical, we need to take in consideration that not all numbers work. So if we pull something up, if we pull this calculator up, if I take square root of 0, I get 0. Cool. If I take the square root of 4, I get 2. But what happens if I do the square root of negative 4. I get this invalid input because there is no square root of negative numbers. There's no even root of a negative number. And so what we want to figure out is for what values does this become false? So we're going to take whatever's underneath the radical So for us, we're going to take x, and we're going to set it to be greater than or equal to 0. And as long as x is greater than or equal to 0, we'll get valid answers. They might not make sense for us, but mathematically they'll work. Normally what we would then try to do is make sure that x is by itself. So if there was more stuff inside the radical, we would add or subtract it over. But there's not. So we'll leave it as is. And instead, we need to figure out what the interval notation of this is. A quick way to do interval notation is draw a line. We got negative infinity, positive infinity, and then whatever our answer is goes in the middle. So for us, 0. Here, since this is an equal to, we're going to use a bracket, and we're going to shade to the right because this is pointing to the right. So we know that my interval is from 0 to infinity. Infinity always getting my parenthesis. So let's do it. Bracket 0, comma, infinity. There you go. Ignore that. That was me just testing. So that is how to do it.